Hey guys, today we're going to do 5.3. We're going to talk about inverse functions, and then we're going to talk about how to find the derivative of inverse functions. So let's first talk about what an inverse is. I can give you a function, and I can give you a function a whole bunch of different ways. I can give you a function as a list of points. I can give you a function as an equation. I can even give you a function as a picture of its graph, right? Let's talk about how to find the inverse of the functions, though. If I give you a function, you can find the inverse of that function by simply just interchanging the x's and the y's. For example, if I give you the function as a set of points, then you can find its inverse. The notation for inverse kind of looks like that. It kind of looks like a -1 exponent. It's just a notation, though, for inverse. You can find me the inverse by just simply switching the x's and the y's. So if your first point is on the original at 1, 4, then you know you have a point on the inverse at 4, 1. And then if your next point is 2, 5, you have a point on the inverse at 5, 2. Okay, and so on. So you can simply find the inverse or points on the inverse by switching the x's and y's. Okay, so if I give you an equation for your original function, you can find the inverse the same way by switching your x and your y's and then resolving, giving you a new equation of x minus 3. So this would be your inverse equation of your original function. Okay? So if I ask you to find me the inverse of something, all you simply have to do is switch the x's and the y's. All right. Another notation that you need to be comfortable with, because it might show up, they might not directly say that these two functions are inverses of each other. They might not directly say that f and g are inverses. So you might see this notation where they take these two functions and do a composition function, where they plug one in for the other, and you can do it either f of g of x or g of f of x. No matter how you do it, you should end up getting them all to cancel, and then you're just left with an x. Okay? Your f and your g's, if you plug them into each other, as long as they're inverses of each other, should end up canceling and just get you an x. Okay? So if that shows up on my test, on the AP test, you need to know that that means that they're inverses of each other. Okay? So because of time's sake, we're going to go ahead and skip this piece here about one-to-one and monotonic, and we're going to go into finding the derivatives of inverses. Okay? Kind of like the product rule that you have to memorize, kind of like the chain rule, kind of like those weird trig inverse derivatives. This is another formula that you need to memorize for me. This is another formula that you have to memorize for me. Okay? If you know that g and f are inverses of each other, if g is the inverse of f, then you can find the derivative of g by taking 1 over the derivative of f with g plugged into it. Okay? So what this is saying is if g and f are inverses of each other, you can take 1 over the derivative of g, derivative of the inverse, right? If you're finding the derivative of g, you're finding the derivative of g's inverse, which is really the derivative of f, with the original function plugged into it at x. Okay, so that's kind of how I memorize it. I have 1 over the derivative of the inverse with the original function plugged into it. Okay? So if you can memorize that, we're going to do some examples now that'll hopefully make it a little bit more clear and better to understand as we actually do some examples. Okay? Let's first start off with this example. They give us f, and all they want you to do is find the inverse value at 3. So not the derivative yet. They just want me to find the inverse of f when x equals 3. Okay? So we know on my inverse of f that there's an x value at 3. We need to find this y value. That's what it's asking us for. What is the inverse of f at x equals 3? Okay? But it doesn't really give us much. It only gives us information about regular f. So what do you know about f and its inverse? Especially with points. Don't you know that if I switch the x's and y's, then they're inverses of each other? So if x on my inverse is 3, then what is 3 in my original? Isn't it the y value? So if I know these values, then if I can figure out what the x value is in my original, then wouldn't that be the same thing as my y value in my inverse? And isn't that what I'm trying to find? So how are we going to find that? How are we going to find the x value in my original, which would be the same as the y value in my inverse? Well, doesn't it give me my original equation? My f of x from up here? And if I know that y is 3, could I plug in a y to my original? It's a little bit hard to solve by hand, right? So what I suggest you do is I suggest you move that 3 over by subtracting it. And then take this and plug this into your calculator. If you take this and you plug this into your y equals, and you look at the graph and solve for x, how do I solve for x when I'm looking at a graph? I find the zeros, right? So plug it into your calculator and find the zeros. You do second, trace, zeros, you do your left bound, right bound, and find all the times that it touches the x-axis. You should end up getting x equals 2. But that's x in my original, remember? We found x in my original. So if there's a point on my original at 2, 3, then isn't there a point in my inverse at 3, 2? And isn't this the answer that I was looking for? I was looking for what the y value was in my inverse when x equals 3. Okay? All right. So now using part A to do part B is asking us for the derivative of the inverse. So if I have f, I'm asking to find the derivative of f's inverse. Can I call it g? And I want to find the derivative of g. So that's what I want to do. I want to find the derivative of g here. Okay? So in order to find the derivative of g, let's go back to my formula. I have 1 over, if I want to find the derivative of g, I want the derivative of g's inverse, right? So what would the derivative of g's inverse be? Well, g is the inverse, then don't I want to find the derivative of f? Right here? With the original plugged into it. The original, if I want to find g's derivative, would just be g of that value, right? Okay, so let's plug in our numbers here. I want to find the derivative of the inverse at x equals what? It says x equals 3, doesn't it? So I have 1 over, I need to find the derivative of f. Do I know the derivative of f yet? Doesn't it just tell me a function? So let's go through and find the derivative of f. I'm going to go ahead and erase this stuff over here. Alright, if f is this function, 1/4 x to the third plus x minus 1, then the derivative of f would be, what, 3/4 x squared plus 1, like that? Okay, and I want that at g of 3. Okay, and do I know what g of 3 is? Well, g, remember what we called g? G was really f's inverse. Do we have a value of f's inverse at x equals 3? Isn't that what we found over here, which was 2? Right? The value of my derivative at x equals 3 we found in part A, which was 2. So now we have the equation 1 over the derivative of f at 2. Well, here's my derivative of f. I just need to figure out what it is at x equals 2. 2 squared is 4. Those go away, and I end up getting 3 plus 1 is 4. So the derivative of my inverse would be 1 over 4. Good? A little bit confusing, right? But I promise you the more you practice, the better it will become. Let's do a few more. If I look at this example, let f be this function, and it says that h is its inverse, and I want to find the derivative of h at x equals 2. So I want to find the derivative of its inverse. So I'm going to do 1 over the derivative of h's inverse, which would be really f's derivative, with the original plugged in at that value, with the original h function plugged in at that value. So this is all the stuff that I need. Okay. Do I know h of 2? No. Do I know f prime of 2? Not yet, but I can find it. Let's find the derivative of that. 3x squared plus 1, like that. But I still don't know what to plug into that, right? Okay, so let's go back and maybe compare some points. I have the h function, and I have the f function. Remember, they're inverses of each other. And do I know any value on either of these functions? Don't I know on the h function that there's an x value of 2, which means there's a y value of 2 in my f function if I flip-flop them? And so isn't that going to help me find couldn't that help me find my x value? If I plug this in here? If I know that y is 2, can I plug it into my f function and solve? Again, if I do it in my calculator can help me solve for zeros and find me my x values. I end up getting x values of 1. That means I have an x value in my original at 1. That means I have a y value in my h of 1. So let's see how that's going to help us here. So now don't I have an h of 2? And one h of 2, what's the y value at h of 2? Isn't that 1? So now we just have to find our derivative of f at x equals 1. So now we're going to plug it into here. We're going to plug a 1 into my derivative. 1 squared is 1. 1 times 3 is 3. 3 plus 1 is 4. So I end up getting an inverse derivative value of 1/4 again. It's not always going to be 1/4. It just happens to be 1/4 in the last two examples. Okay? Let's do one more for me. Okay? If g is the inverse of f, and then it gives me some information. It says that g of 2 is 5, that f prime of 5 is 1/2, and I want to find the derivative of g. So g and f are inverses of each other. If I want to find the derivative of the inverse of g, I want to find 1 over the derivative of g's inverse, which is really f, with original g plugged in at x equals 2. Right? 1 over the derivative of g, which is f, with the original g plugged in. So let's see what I have. I have 1 over f prime of, do I know what g of 2 is? Ooh, don't I know what g of 2 is right here? It's 5, isn't it? So can I plug a 5 in? I don't even have to do any work on that. And do I know the derivative of f at 5? Ooh, don't I know that right here? So can I just plug that in? This one's an easy one, right? I don't even have to do anything on this one. I've got 1 over 1/2. That looks funny though, right? We don't ever divide fractions. We only multiply by reciprocals. So instead of dividing by 1/2, can I multiply by 2 over 1? And so then I end up getting g's derivative at x equals 2 is 2. Okay? All right, so make sure you practice that formula. Remember, it's simply 1 over the derivative of the inverse with the original function plugged into it at that x value. Okay? Your homework for 5-3 is going to be a worksheet. The directions might change a little bit as to what questions you're doing on that worksheet, so I'll let you know in class what questions I want you to do, okay? But again, the more you practice these types of questions, the easier they'll become, so please make sure that you practice, all right? I'll see you later.